Good afternoon, all of you. Today, your practical is field evaluation. Before start the practical, I have to give small announcement to you. When you are asking questions through the chat box, please send them to everyone, not only to host. Okay, now Dr. Chamila Vijay Khan will conduct the practical.
Okay, right. Thank you, Madhubhashini. So, seeing you after a long time. Can you all hear me properly?
Yes, sir.
Okay. So, in fact, there were some delays in organizing this practical because, when you say field evaluation of soils, you should go to field, right? So I was just wondering how that can be done without going to the field. And there were some problems, in getting some information, and I later explain what we did. So now I want you to pay your attention, and Udaranga is recording the session. So this will be the video for this particular practical recording of this thing. And I will again upload another video to LMS, and that will, you can use that particular video for certain activities given in this, given as the assignment of this practical, right? So if you have any questions, so if there are any areas which are difficult for you to understand, please raise them. Maybe you don't have to wait until the end, so just send a text or just open your mic and tell it. So now I have a small presentation prepared for this practical. I mean, it's not a complicated thing, but we'll see. Now, which screen can you see? Is it the projected slide or the other part? Which part you can see? I mean, is it the projected slide or the one with the background, other elements?
The background, sir.
Okay, then I'll share again. Now, now I think it's the projected. Okay, right. So now this practical is the field evaluation of soils and land, right? So it's not just field evaluation, but so I think before the closure of the faculty for this point, I think second wave was, I don't remember. Yeah, probably second wave. So some of you participated in this practical in the field that is close to that big girls hostel, right? So those who, I think one group was, completed, and the other two groups, there were only few people left. So we had the session, but I think, I mean, this practical, for those who did the practical, I think you have some more, extra experience with the soil sampling and all that. But for those who did not attend that practical, then you will have to go with this. So there will be a difference between that particular practical we conducted in the field and the one that I'm doing today, although the topic is almost the same, right? So now just wanted to start with this: why we evaluate soil or maybe land, whatever. Usually land and soil are kind of used interchangeably because mostly when it comes to land, it is the soil that dominates, right? So, but in the real term, land is different from soil. So, even if you go for a land evaluation or soil evaluation, there are some common elements that you consider, right? So we are focusing more towards soil, right? More on soil, and at the same time, land will also be evaluated, right? So please understand that. So why we evaluate soil, right? So we can decide a crop or any land use for that particular land, right? So say if you want to plant something, let's say coconut or tea or something, then we have to evaluate. Usually, in our traditional system, people will go to the particular land and clear it and then just cultivate. But if you do the cultivation in a scientific manner, then you have to evaluate and check whether that land is suitable for this particular crop or the land use or not. Then only you will go for the planting activities, because otherwise this activity will not be sustainable, right? And then sometimes we do soil analysis or land, soil field evaluations to characterize the soil, right? So now we don't know what soil is there if you if you go to a particular place. So there are some maps already prepared with the analysis of representative soils, and then we kind of extrapolate. So we analyze, let's say if you take Sri Lanka, we have about 150 benchmark sites or initial assessment sites, and then we how do you say, predict the other areas where the properties of the soils surrounding that initial evaluation sites, right? So I'm not going to talk about those things in depth here in this practical, just to have an idea. Then assess the status of the soil. It is something like that. Now, various things happen now these days. People are concerned about the fertilizer application, and they say that organic is better and kind of things. So let's say if there's a land where a particular crop is grown, let's say tea, and you go to that particular land and try to find out what is the current situation of the soil in that particular land, whether it is degraded, whether it is sustaining its health or initial properties or something like that, right? So these are the three main reasons why we evaluate soils or land, right? So you can just say soil, I mean, it's okay, right? So then how we evaluate. So there are various ways to do this. You can learn about these things in depth if you enroll to some of our advanced courses in third year. So we can do direct visual assessment. Visual means you go to the particular land and then just observe. I think the first group who came, you just had a look around and then you decided various things. Right? So there is now direct visual means you observe the soil, right? So the things directly related to the soil. And when it comes to the indirect visual assessments, it is the things other than soil which can give you some clues about the the properties of soil. For example, if the plants that you see in that particular land are having some sort of poor growth, leaves are yellow, right? So in simple terms, so you can expect some nutritional deficiencies, right? So that means the soil is not capable of supplying the amount of nutrition required by the plant, right? So those are indirect visual assessments. So by looking at the plants, you explain the condition of the soil. So those are indirect assessments. And you can, of course, directly measure the soil properties using various instruments. Or maybe you can take samples to the laboratory and do the rest of the analysis. So the last one, measurements will give you numbers, right? So those are more, how do you say, more accurate than these visual, direct and indirect visual assessments. If you have a lot of experience, of course, these two, the first two, could be more, very much accurate, but you cannot give numbers, right? So these are the things, in the field, we were trying to feel the soil and see what's happening, what is the texture, whether it is sandy or clay and kind of stuff, whether you have rubber or, whether, it has a lot of organic matter kind of stuff, but we cannot do them, through this online stuff. And I think in the first year you observed the soil profile and you felt, all of you participated and you saw how the soil profile, looks like kind of thing. So in our, today's practical, we focus on indirect visual assessment because we cannot really go to the place. And so what we are trying to observe is the surrounding area and try to, come to certain, how do you say, judgments or to explain certain properties of the land and the soil, right? So we are not going to the field, right? So we cannot go to the field because through Zoom, I don't know if there was a way, teleporting or something, then we could have done that. So unfortunately, you have to stay behind a screen to study the field assessment of soils. Now, for this practical, I used this small drone. It is called DJI Mavic Pro. I think some of you may have, already used some of these stuff. These have become affordable in the recent past. And the one that we use is a kind of, it is basically used for, entertainment and but it has more capabilities, right? So this one has a kind of flight time of 27 minutes maximum with one battery, and it can go up to 7 kilometers theoretically. That's what they specify, but there are some limitations, and it has autopilot guided by the GPS and has a camera of this 12 megapixel sensor. And it has also some safety features like other cameras, distance meters, built into it. And you can connect it to your mobile phone through the remote controller. And there are some applications developed by the manufacturer, so you can get the full control of the drone using your mobile phone. I think you must have seen in the news also in the recent, when they try to track the people who violate the quarantine laws and kind of thing. So this is what they are usually using. And it has some smart features to follow objects. If you define, okay, you follow this object and it will keep on following, right? So that type of things can be done. And when we connect it to this particular software, this drone deploy software, it can fly in a designated path, as you can see in this green color line. This is the flight path, and along the path, drone will take photographs. So in this case, number of photos is not given here. So you see that the software shows you the area 4 hectares, and you need one battery to cover the area. The flight time is 4.49. 4 minutes and 49 seconds. Altitude is 45 meters. Right? So we can set all this stuff using this software and upload it to the drone, and then we don't have to do anything. It will just automatically fly to this designated path and will start taking the photographs as we specify. Right? So for example, now this is the starting point according to this plan. Now drone will start moving along this direction, and it will take one photo at this point and another one here, another one here. Like automatically it will take the photographs and store it in its memory, and we can later use these photographs to analyze the land features, crop features, and many more. Right? So we use this basic free plan of this software, but advanced users can use the paid version, which has more functions. And we also use another software called Agisoft Photoscan. It is a professional photo analysis software where you can analyze the photos taken by the drone. You have to upload all the photos taken by the drone during that planned flight, and this software will analyze. So we call them aligning photos. So because all the photos are tagged with its geolocation, that means the GPS point, and then this software will analyze those GPS locations, and of course the pixel analysis will be done, and then align the photos like this. So one, and then you can use this software to develop a digital elevation model. That is, I think you must have heard these things. The elevation of the land, topography, 3D model can, I show it to you later. And then create orthomosaic image. The software can merge all those photos taken by the drone into a large mat, right? So where all the photos will be combined. So we call it orthomosaic. And then something called dense cloud can be generated. I will show it to you. It is a 3D model of the land, right? And then we can also generate contour lines. I am sure you must have heard what are contour lines. So those are the lines connecting the places which have similar elevations, right? Heights of the land. So now what we are going to do in this practical today is to observe the surface features of the land, and then I have prepared a sheet, a field evaluation sheet, and you will have to fill that, not during the practical, but I will upload it to LMS. You can download it and fill it. So it is a kind of, it is in the form of a form, right? In the form of a form. So all you have to do is click on those boxes and just type in. I think it will work even with mobile phones. And if anybody is having difficulties in filling that form, probably you can, I don't know, print, if you have a printer, print it and then fill it and upload it to the LMS for the, assessments, right? So that is what we are going to do. you are going to observe what the things that I'm going to explain, and then fill that form. So in support, to support you, I mean, you cannot ask questions from me, or all the time when you fill it. So maybe Madhubhashini and others, we will give them an extra day or two to do this, right? Because usually you give just one day, right?
Yes, sir.
So for this one, we will give a couple of days, because this might be new to them. I don't know. Some people might have little, difficulties in this, because I am also doing this for the first time, and so I'm also kind of learning from this, doing this practical.
Okay, sir.
Right. So now let's have a look at the things that I have gathered for you. So let's first move to the so I'm going to first show you the form. This is the form that you have to fill. Can you see it, Udaranga?
Yes, sir.
Okay. So this is the form. We will upload this to LMS. You can download this. And when you download it, probably you're not downloading it. When you try to open it with Microsoft Office, it might say that this one has macro enabled kind of stuff. Please accept them, because this form fields need some scripts. So that is why it is called macro enabled. So what you have to do is fill this form. So the first thing is index number. So you have to type in your index number, and you can click the date, and the site ID, you can give any name to the site that we are going to study today, and the coordinates of the site. This you can find from certain things that I'm showing you today. Well, but I recommend you to use Google Maps, right? So you know how to use, probably you may have used it, and I think you should learn how to use Google Maps, right? So if you use your mobile phone or PC, then you can find the coordinates in the Google Maps. So try to fill these north east coordinates by checking the Google Maps. That is also part of the exercise, right? So I can give you the values without any problem just right now, but I want you to learn that. So this is the area that we we are going to evaluate today, right? So this is the same piece of land we evaluated, with one group. If you, for the others, this is the land right in front of that big girls hostel. And this is the same land which is being used for the farm practice course for I think the last couple of years. And these are the hostels, girls hostels, the units, and these are the blocks, right? I think you stayed in that hostel for some time, so you know the area. And here we have this rubber plantation and some other abandoned lands here, right? And we have the old piggery, and here we have the polytunnels, which are which have been constructed along with this dialogue and our farm, right? So, and there are some fields, elevation. So you can get the elevation also from the Google Maps, or you can use some of the material I have provided with this document, right? So at the end, I have given you this digital elevation model as well as the contour map overlap onto this orthomosaic, right? So this aerial photograph, right? So this is the land. So there are some questions asked. Present vegetation, ground cover. So you can write the things that you feel, right? So if you have experience with the land, the real experience, then you can write those experiences as well. So just limit your answer only to this box, right? So we don't expect very long answers, just in point form. Use commas to separate or commas or slashes to separate the points, right? Then possible influences of external factors to the sites. Now here I told you that we are basically thinking about the soil and crop. So now you see, for example, when you have a look at this land, now in this upper part of the land, there are no much, residential areas or anything that can influence this land. But here we have the compost unit, we have the old piggery, but now there are no pigs in it. And we have hostels here, right? So there can be some external influences to the land because of these units and entities, right? So just think about what are the things that can happen. And then drainage pattern and expected conditions. So I'll explain to you later. When you look at the contour map, you can find out to which direction the water will move along the land, right? So we cannot say much about the real soil drainage conditions because we cannot, feel it, and we don't know what is the soil, what are the properties of the soil. So just, you can talk about the direction of water flow, right? In which area will be the highest velocity. I mean, those things are up to you. You can think about it. So I will give you later, those information, which will help you to write those answers. And then proneness to soil erosion. I think you have a basic understanding of soil erosion. If the land is having a steep slope, then the erosion is high. And if the land cover is gone, if the soil is exposed, that area is prone to soil erosion. Right? So just have a look at the surface conditions and slope, which you can estimate by looking at the contour lines. You can talk about in which parts of the land could could be having high potential for soil erosion, and which parts of the land may have low potential soil erosion. And that kind of information can be written here. And then sources of inputs. This is somewhat related to external influences. So what we are talking about is nutrients, waste material. Now this mostly, when you go to the field, you can feel these things, right? Say if you have a lot of cattle around this area, then they are cow dung and kind of things. And when the piggery was here, their excreta was released to the land. So those are the sources of inputs, right? And I'm giving you the answers to these questions, at the same, during the explanation, right? So we have the compost unit, and there can be, wastewater moving out of the compost site. And then there's another question called estimated depth to the groundwater table, right? So that you have to find out. I think those who were in the class, you learn how to say it. Now, when you have this digital elevation model, you can easily calculate that, right? So we'll talk about that in a while. And then level of disturbance to the site. So this is not a natural land. So it has been used for the farm practice course, and there are some activities going on. So you just can explain it in a few words what type of disturbance you can expect, right? Since you haven't visited the land, you cannot say all the things, but you can expect certain disturbances, right? And I have also given you these two figures just to get some orientation, and the contour lines are also given in this particular figure. You can see that some numbers written inside these boxes, those are the elevation values in meters. And for example, if you take this particular point, it is 50 meters above mean sea level. And if you take about this one, it is 44 meters. So that is how it goes. And now, if you take any point along this contour, I mean, say if you take this contour, then the elevation is 44 meters. And when you go down, it will be, now I think the same contour continues like this. So still it is 44, and here in this area it is 42. Now these contour lines have been prepared with 2-meter intervals, right? Otherwise it will be very congested, and if you want to have 1-meter interval. So that is how it goes. And this is the thing called digital elevation model. So you can see that a color has been assigned to different elevations. Now this red color, you can see, shows the highest, the points with highest elevation. And the yellow is next. You can see these treetops have a higher elevation. And of course, you cannot say the exact elevation of the land, but when it is covered with vegetation like this, you get the elevation, including the plant height. And when you come down, you can see that this area has a kind of slightly higher elevation. And then this blue, the dark blue has the lowest elevation. Right now, if you take a look at this figure, 36 is the lowest, right? So the scale goes from 36 to maximum is 70 or something. So now this area is the place with lowest elevation, right? But this is outside the land that we are focusing on today. So the land that we are focusing is here, right? So now this is the area where you find this paddy field, right? So you can estimate the depth to the groundwater by looking at the elevation of this paddy field. Usually if you had observed, this area is always inundated, covered with water, because the groundwater table is almost the same, as the level of the ground, right? So now when it comes to the elevation of the site, you can get the average elevation or any place inside the land which can briefly. So don't take the highest point and the lowest point, but you can find a kind of middle point of the land and then put that into that box, right? So this is the form that you have filled. So we will see the other aspects that I have to show. Now let me share this software. Can you see the software interface?
Yes, sir.
Okay. So these are not, magic. I haven't followed any courses, uh, on this using this software. So you also can download these things and try these things out. So that is what I wanted to show in I mean, do in this practical as well. So now you see that in this software you can see that plan that I showed you. So now if you take a look at this window, this particular, you cannot say this window, but this particular pane, there are various items: orthomosaic, DEM, that is digital elevation model, dense cloud, tile points, and you can see cameras. Now these are the photos that were taken by the drone, as I told you. Now what the software has done is, combining all these photographs into one single, how do you say, map, right? So that is the thing we call the orthomosaic. That is what you see right now. Right? So this is the orthomosaic. So it has combined. This is not a single photo, right? So we have, I think in this particular photo shoot, the drone was flying at 80 meters above ground, and if it had gone further up, then it could have captured this whole area in one image. But at that time, there will be less details. So lower the flight elevation, more details that you get. Right? So now, since I didn't want to complicate this thing, I flew the drone at 80 meters elevation, and it has taken 153 photographs in his flight. Right? So we have combined all those photographs into one thing, so we call it orthomosaic. And this is the digital elevation model that I showed you. I have included in it in your field evaluation sheet. You can see in this one, I think it's clearer than the one that I showed you. See that the red areas, it is 78.4 meters high in elevation, right? So if you go further down towards that paddy field, so the elevations are like 36 meters, right? So here we can see a lot of water. So the groundwater table is almost near the surface of the land. Right? Now you can see that in this particular land, this is the land that we are evaluating today. The contours are going like this, right? Somehow I haven't generated all the contours, only as selected ones. So the 46 meter contour goes like this, and this one is there's a 50 meter contour, small one here. See, so these are coconut trees. Right? There were some coconut trees. That is why they, have higher elevations. But here, let's see, this one has an elevation of 44 meters. Right? So now there's a 48 meter contour line. So these are coconut trees. So you get some higher values. Anyway, the general pattern of the contour is like, they go like that, and then go along this area. This is where you find the road, right? In front of that hostel. So kind of now if you take a look at this area, this one is 38, right? 38. Now this area has about 40, and this one 40. Now this contour is somewhere like 42, right? And this one is 44. And when you go further up, there will be, I think this one is right. So where you can get more details if you increase the number of contour lines, right? That means 1 meter interval depth, interval or something. But since it becomes very complicated, I did not generate those contours. So now you can see that the slope of the land goes like this. Right? Now you can see the slope here. This light color somewhere around this, and then it moves down, right? So you can see even in these areas, the slope somehow goes along this direction. Right? So now you can expect the water movement along the slope. So for example, now this area has some higher ground. So this is almost like flat, and the water can move in these directions that I'm showing, and finally end up somewhere around these low-lying areas. Right? So you can see when you click on this contours, it shows where the contour is going. Right? So now this is the digital elevation model, so you can zoom it in and see what's inside. So it is not really giving you the land, but you can see that trees are also considered as the land surface. So you should be able to differentiate the trees from the other, the surface of the land. And this is what we call dense cloud. So it is a 3D model of the land. So it takes about 2 hours to process this thing in this computer. So you can rotate, and you can see a 3D image of the land like this. So you can see that you can turn it around. So had I flown the drone at a lower altitude, we wouldn't have got this type of voids, right? Because the drone was high up, so it cannot see these areas. So if it was flying, let's say 30 meters or so, you can see more detail. But at that time, the number of photographs will increase, and this model will be very complicated. Right? So you need very fast computers to process. So I did not try to make it complicated. So you can see that this is the paddy field, the low-lying area, and this is the road going towards the hostels. And you can see this Y junction where you can go towards this composting site. And this is the piggery, and these are the polytunnels. Right? So you can process this image with more high quality images. Again, it takes a long time to process, so I did not try to go into detail. Right? So you see that now you can see the depth. So these are the contour lines. So you can zoom it in and see how the surface looks like. So you can turn it around. Now you can see that in this area, the slope can be clearly seen. Now this is the composting site. So you have a very low-lying area, 38 meters here. So it goes like that. So the slope, as I showed you, comes like this. Right? So now by looking at this contour line, these contour lines and these 3D models, you can say certain things about the soil. For example, now in this area, you can expect more soil erosion because the slope is relatively high. But if you come to this area, it is a kind of a valley. So all the soils that have been carried out, washed away by the rainwater may have deposited in this area because the land is kind of relatively flat and the rate of or the velocity of the surface runoff is less. So there's a higher chance of getting deposited in this area, right? So now, so by that way, you can say if you go along this contour, these areas, you can expect higher, I mean, very poor, the fertility of the soil may be poor in these areas. But since the material will be deposited in this area, you can expect more nutrients, right? Now, I think in that practical, we divided you into groups last time, but since all of you are having the same information here, so we don't have to go into different groups individually. You can, you know, describe the whole piece of land, not in, you know, limits, selected areas, right? So just have a look now, because when we are, I mean, I cannot upload anything interactive like this. I mean, you can, you know, use this interactive or, you know, turn this around and see all those stuff if you have the software with you. So I mean, there's no way I can you know, provide that information. So I mean, I will upload a video where I have you know, done something like this. Now I have moved the camera so you can see the land features. So that will also be uploaded to the LMS. So you can watch that video and you can use the video slider here and there and see, I mean, observe the important aspects, right? So that will also be available to you to do this practical, right? So now here we have the piggery. So if we had pigs in this piggery, you can expect, you know, there are, you know, waste coming out of this thing and moving down this slope. And maybe the soil will be rich in nutrients in this particular area. So those are the things, right? So now that is what I had to explain to you. So so this is not just field evaluation, so it has some more aspects as well. So now you can see that these blue squares are the photographs taken by the drone. And so now it may have moved along this line while taking the photographs. And so these spheres indicate the GPS location of that particular photograph. So it has taken some photographs from the sides. You see that some are kind of slanted and some are horizontal, right? So these are the photos that have been use for this particular model. Okay? So that is what I have to explain. So what you have to do is use the facilities that I have provided and write or answer the questions given in that field evaluation sheet, right? So we don't expect a professional's, views, but I want you to think, right? But the first group may have some advantage because they visited the field and they felt it in the the real field conditions. So, but unfortunately, I cannot do much about that. Maybe that the people in that group can help the others somehow for the others to fill this, but don't try to copy. I mean, you can of course share information, but don't copy. Now, say if somebody says, okay, this is the thing, and others will also follow the same thing, we don't tolerate that. And we want each and every one of each one of you to work on this alone and learn something, right? And we know who's copying and who's, I mean, we have a lot of experience marking your, what do you call, practical lab sheets, and we will give low marks, right? So when it comes to the sheet, we don't give marks, I mean, equal marks to all the questions, because there are some questions where you have to think about certain things. For example, now these are just simple values, so you can find out, and we will give more marks to those things which you have to think and write, right? So think about that. So spend some time and fill this. So we will give now, today is Friday. You can submit this by Monday, right? So then we will give marks. So use the form that I have prepared, and unless you have difficulties in filling that form, I mean, you can maybe print it out, or you can use your own form. Okay? So otherwise, it will be difficult for our staff to, assess these assignments. Okay, so do you have any questions or anything to get clarified? And then we can discuss. You can ask any question and don't wait for the others to ask questions. If you have questions, just ask. Just think that this is just a regular class. The thing is, now we can do a lot of things, and the world is now moving, right? So we want you to move with the world. So that is why I am trying to give you this, I mean, some clue, some not clues, but some insight into the things that are being used by the scientists. Not only scientists, now these software are available for farmers, right? So, I mean, this photo scan may be, used by the specialists, but that drone deploy software, even a person with simple understanding of the drone and the software can use it. And if the drone is equipped with specific, cameras which can measure the infrared spectrum or something, then you can get those photographs as well. And the software will automatically analyze the nutrient conditions in the soil, right? So all those things are there. So do you have any questions or clarifications required? Madhubhashini, Ridma, I need a small feedback from you.
Sir,
Yeah.
excuse me, sir. Those who did this practical before, they should submit this assignment again, sir.
Yes, yes. I did they submit the previous practical,
Yes, sir.
Madhubhashini? Anyway, we will evaluate this one because it will be reasonable for all of you. I mean, for the others as well. Otherwise, we will not going to be analyze. I mean, two different assignments. Right? So those who did the practical also, I mean, before you can fill this particular form.
Okay, sir.
And that's why I told you that they might have a kind of slightly higher advantage. Okay, there are some questions. How can you show us how we should take coordinates by using Google Maps or any software while answering the question? Okay. Google Maps is for layman's use, right? So it is not very complicated stuff. So open your browser if you are using a computer. If not, there's an app in your mobile phone, Google Maps, right? So I'm going to show you the map in my computer. So so okay, can you see the map now? Map of Western Province. Now there are layers in this Google Maps. You can just click this satellite if you want to see the satellite imagery, or you can just go with the street map. And there's another map called terrain map, where you can see the elevations, just like the one that I showed you. So Google has developed a terrain map using satellite imagery instead of drones. You can see the contour lines. So this is a kind of large scale map, I think 30-meter resolution. So if you want to find the location of a particular place, you can right click. You can see the coordinates. 6.49130. This is N and this is E, 80.35. There are different coordinate systems. Probably you may have learned the other type where you use degrees, minutes, seconds. Udaranga, how do you call that system?
Decimal degrees and degrees minutes second.
Yeah, this is decimal. The other one degrees, minutes, seconds. Right? Yeah. So that will also be accepted. So if you use Google Maps, I think you can see this decimal thing. So you can just see that now. Say if you want to get the elevation of this particular point, just right click and you can see the coordinates. If you want to see the elevation, you can either use this terrain map, right? So when you zoom in, you can see the contour lines. Let's say if you want to get the elevation of this particular point, try to find the nearest contour, right? So here it is 600 meters. So according to this figure, this should be less than 600, I think. So now here it is 400. So you can see how many lines? 1, 2, 3, 4, 5. So this is like you have to divide this. There's a difference between two lines. It's 200, and there are 5 lines. So you can simply get the elevation, or if not, you can use this Google Earth. Earth is also available online now. Right? So you can go to Google or Earth. It will give you more information. Right? So there's an app for the Android as well, and not the Android, I mean for the mobile as well. It takes some time to load. I'm using this for the first time in this computer, so it might take some time. So if you have Google Earth, you can see the elevation, the coordinates. Here it is. Now you can zoom this globe in. Right? Now you can see Kamurupiti here. Right, and you should be able to locate our faculty. So it is here. Right. So you can see this large hostel. So you have a name for it. So now you see that you can zoom in, but I don't think it's not that clear. I mean, after so now you see that elevation is displayed here in this right hand corner. So when you move your mouse, the elevation will change, and the coordinate is also given. But here it is given as this degrees, minutes, seconds format. So it's okay to, I mean, write this format as well. Right? So, but there can be slight differences in the elevation because you know that drone's elevation may change a little bit. You know, may be different from the elevation shown by this Google Maps. Right? So here it's like 17 meters, but with the drone imagery that we have taken, it appears like 38 meters. Right? So there, just forget about those things. You just use Google Earth or Google Maps to find this information. Right? Now you can see that here it says camera, right? This is the altitude of the camera, not the elevation of the land, right? So it's like if you place a camera about 184 meters above the ground, you will get a view like this. So when you go up like this, you can see the camera altitude is like now 6,400 meters. So if you go further up, let's say 14,000, like. So if you fly in a plane, a commercial airliner, you will fly at this altitude, right? like 30,000 or maybe 45,000, a little bit more. So you will see the land like this. So this is the elevation of the camera, not the land elevation, right? So that is how you take the what do you call it? Elevation and the location. Any more questions? No questions?
Maybe no more questions, sir.
Okay, so that means they understood. Or they understood nothing.
Maybe 100%.
So it can be either end. So maybe 100% understood or 0% understood. Hmm? So I want to hear some voices from the crowd. So let me ask from some couple of guys. AGAB 4828. I don't know your names, but 48 28. Can you talk? Or any volunteers? 4845. It's the boy. It's me. Nobody's talking. Have they fainted?
May not, sir.
Yeah, it's up to them to clarify the things they want. What do we do, Darang?
If there's no question, shall we wind up?
Yeah, I can wind up. So we will wait, and those who want to leave, you can leave, and we will upload these things to the LMS later tonight, so you can get them and
So the
finish
deadline
it
for the practical?
Monday. Yes. If you want, you can discuss with your friends, but don't copy. We will catch you. We can easily detect the people who are copying and who are genuinely writing, right? So, and whatever you do, those will be for you, right? So if you copy, you will get nothing, and at the end you will be the one to suffer. Yeah, though if you have any questions, you can ask. We will stay online for a couple of minutes, and I want the feedback of Madhubhashini, Ridma, and others. How did you feel this? Because this is the first time I haven't tested this before.
So this is a new one, I think, for student, and I think that it is very important for their future studies.
No, yeah, that what I'm asking Madhubhashini is, do you think they would have understood it?
Yes, sir.
The things were
I
clear?
understand. Yes, sir.
Okay. How about Himandi? You are new to agriculture, probably you may have used these things when you were studying. Did you understand? Is she online? Kilini was there? She has left.
Yes, I understand it.
Okay. Udarang, I think he knows he's our GIS man, so I'm not going to ask him.
Yes, I think it is very much interactive and very active session. I hope, because during this pandemic, this is the very much beneficial method for giving this knowledge. I think your job is 100% successful.
So let's see with the reports.
Okay, sir.
Okay. So students, if you don't have questions, you can leave. And if you have any questions, you can raise. We'll be waiting here for some time. Udaranga, are you in the faculty or?
Yes, sir. Faculty.
Yeah, if you want, you can leave.
No, sir, no.
But you are recording, right?
Yeah. Still I'm recording. No, it doesn't matter, sir.
Okay.
I can wait.
Okay, there were no more questions, I guess. So let's leave Udaranga.
Okay, sir. So wait for a while.
So this is the last practical of this semester. Please submit your reports on time, and I would like to thank all of the academic and non-academic staff members and all of you for your active participation, and we hope you have a good understand all practicals. Okay, then let's wind up this session. Thank you for your participation.
Madhubhashini,
Yes, sir.
Madhubhashini, I think it is better if we can prepare kind of feedback form and send to the students regarding this practical program, this online thing.
Okay,
Because,
sir.
this is new. This is the first time that we are carrying this thing out. So I would like to, I want you to kind of, we have that teacher and course evaluation, but that will not specifically address the things in this online context. Can you prepare a kind of small survey about their views? I mean, like things like, what are the difficulties they had? What are the good things that they saw in these practicals? Kind of, how about using this type of online things blended with the real practicals kind of stuff? Can you prepare the questionnaire and we'll later discuss and fine tuning it and then distribute among the students?
Okay, sir. I will prepare, sir.
Yeah, you can just use Microsoft Word and put the questions, with that, how do you say, that scale thing, agreed, then kind of, how do you call it? Scale, right? Likert
Yes, sir.
scale, or whatever, I don't remember that. So you can prepare that and you can just prepare the questions. You don't have to say agree because we can put them in the form
Okay, sir.
for the whole practical program. Right?
Okay, sir. I will do, sir.
So others can also help Madhubhashini to do that.
Let's wind up this session, sir.
Okay, right. So I will upload the material to the LMS.
Okay, sir. Thank you, sir.
Right. And thank you, everybody.